Hey everybody, in this video we are going to solve some quadratic equations by factoring. A quadratic equation is any equation in which the greatest exponent is 2. Now that 2 right there being the greatest exponent means there will be 2 solutions. If the greatest exponent is 1, there's 1 solution. If it's 3, there's 3 solutions, and so on. So here we will be looking for 2 solutions. Now when I solve a quadratic, the first thing I look for is a common factor that can be factored out of all 3 terms on this left side when it's set equal to 0. And I don't have a common factor, so I move to looking for 2 numbers that multiply to c, which is 4, and add up to b, which is -5. So 2 numbers that multiply to 4 and add up to -5, and those 2 numbers would be -4 and -1. -4 times -1 is +4. -4 plus -1 is -5. So my factored form is w minus 4 times w minus 1 equals 0. Now from here I can get my 2 solutions. When 2 factors are multiplied together and their product is 0, that means that at least one of these factors is 0. So we're looking for what values of w would give me a factor of 0. So if I put a 4 here, I would have 4 minus 4. That would make this factor equal to 0. So w could be 4. Or if I put a 1 here, 1 minus 1 is 0, so that would make this factor a 0. So w can be 4 and it can be 1. Y squared plus 5y minus 84. There is no greatest common factor that I can factor out. So I will look for 2 numbers that multiply to -84 and add up to +5. So they multiply to c and add to b. Those numbers are -12 and 7. -12 times 7 is -84. -12 plus 7 is 5. So my factored form is y minus 12 times y plus 7 equals 0. So my solutions are 12 because 12 minus 12 makes 0. And -7 because -7 plus 7 makes 0. Okay, now this method works really great when the leading coefficient is 1. And throughout this worksheet it will always be 1. There is a difference here though on number 2. Notice that number 2 I have p squared minus 5p, but I don't have another term like I had here. I don't have a c term. So here I do have a common factor I can factor out of these 2 terms, and that common factor is p. P squared divided by p is p, and -5p divided by p is -5. So there is my factored form. And from here I can find my 2 solutions. So in order to make this factor a 0, I would simply make p 0. To make this factor 0, I would make p 5. 5 minus 5 is 0. Here I'm back to 3 terms. I do not have a greatest common factor to factor out. So I'm looking for 2 numbers that multiply to make 10 and add to make -7. Okay, so to multiply to 10 and add to -7, I could use -5 and -2. -5 times -2 is 10. -5 plus -2 is -7. So I have z minus 5 times z minus 2 equals 0. To make this factor 0, I would set z equal to 5. To make this factor 0, I would set z equal to 2. My next one is 2 terms again, and there is a greatest common factor. That common factor is w. So I can factor out a w. W squared divided by w is w, minus w divided by w is 1. So to make this factor 0, I would say w is 0. To make this factor 0, I would say w is 1. Okay, now with that, let's turn the page, and we've got a little difference on this next page here. Here I have equals negative 32 instead of equals 0. Anytime I have a squared term and a first powered term, I want everything on the same side set equal to 0. So I'm going to add 32. And that actually cancels out on both sides. So I have z squared minus 8z equals 0. And I have a greatest common factor, or a GCF, that I can factor out, and that is z. Z squared divided by z is z. Negative 8z divided by z is negative 8. So I can make this factor 0 by setting z equal to 0. I can make this factor 0 by setting z equal to 8. Okay, once again, I'm not set equal to 0. I have a squared term and a first powered term, so I want to be set equal to 0. So I will add 12 to both sides, and once again, it cancels on both sides. So I have m squared plus 2m equals 0. And there is a greatest common factor there, and the greatest common factor of these two terms is m. And when I divide m squared by m, I get m. And 2m divided by m is 2. So I can make this factor 0 by setting m equal to 0. And I can make this factor 0 by setting m equal to negative 2. Here I have a squared term and a first power, so I want to be set equal to 0. So I will add 58. And it cancels on the right side, but not the left this time. So I have b squared minus 17b, and then 14 plus 58 is 72. Okay, so I'm looking for two numbers that multiply to 72 and add up to negative 17. And those two numbers are negative 9 and negative 8. Negative 9 times negative 8 is positive 72, and negative 9 plus negative 8 is negative 17. So I have b minus 9 times b minus 8 equals 0. So I can make this factor equal to 0 by setting b equal to 9, and I can make this factor equal to 0 by setting b equal to 8. Once again, I have a squared and a first power, so I want it to be equal to 0, so minus 4 on both sides. And I get z squared minus 5z equals, minus 6 equals 0. Okay, so I'm looking for two numbers that add up, or that multiply to negative 6 and add up to negative 5. Multiply to negative 6 and add to negative 5. Those numbers will be negative 6 and 1. Negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. So I have z minus 6 times z plus 1 equals 0. Okay, so I can set this factor equal to 0 by setting z equal to 6, and I can make this factor equal to 0 by setting z equal to negative 1. And we'll do one more here. I have w squared minus 2w equals 99, so I do have a second power and a first, so I want to be equal to 0. So I have w squared minus 2w minus 99 equals 0. So I'm looking for two numbers that multiply to negative 99 and add to negative 2. And those two numbers are negative 11 and positive 9. Negative 11 times positive 9 is negative 99. Negative 11 plus 9 is negative 2. So I have w minus 11 times w plus 9 equals 0. I can make this factor equal to 0 by setting w equal to 11, and I can make this factor equal to 0 by setting w equal to negative 9.